And here we are trying to prove that the sum of the first n Fibonacci numbers is the same as fn plus 2 minus 1, where we have the familiar Fibonacci sequence, where f1 equals f2 equals 1, and where fn equals fn minus 2 plus fn minus 1. And we proceed by induction. So we let Sn be the statement that the sum of the first n Fibonacci numbers is the same as fn plus 2 minus 1, and we go on to establish the base case. And so the base case is statement 1, which states that the sum from 1 to 1 of fr is 1, because that's just f1, and f1 plus 2 minus 1 is f3 minus 1, which is 2 minus 1, which is also 1, and so we have established the base case. And so here we have the induction hypothesis, which is SK, which states that the formula works for all n less than or equal to k. So with the induction hypothesis, we have supposed that for every single integer up to k, the sum of all the Fibonacci numbers from f1 to fk is given by fk plus 2 minus 1, and we want to know whether or not statement k implies statement k plus 1. And so we are required to prove that the sum of the first k Fibonacci numbers plus fk plus 1 is equal to fk plus 3 minus 1, because fk plus 3 minus 1 is the same as the formula fk plus 2 minus 1, but with 1 added to the k. Now, the sum of the first k numbers is equal to fk plus 2 minus 1 by the induction hypothesis. And so the total sum we've got here is fk plus 2 minus 1 plus fk plus 1. And that is the same as fk plus 1 plus fk plus 2 minus 1. And those two added together by the Fibonacci formula are fk plus 3. And so we arrived at our result, fk plus 3 minus 1. And so we showed that S1 was true, and that sk implies sk plus 1. So Sn is true for all n which are members of the natural, the positive integers, by induction.